Hello student, this is the problem number 9.5 and it states that suppose you send an incident wave, let's suppose Gi is the incident wave of specified shape Gi, this is the shape, and down the string it gives rise to a reflected wave. We have a reflected wave and also a transmitted wave. Imposing the boundary conditions, there are two boundary conditions. uh, I will show here, and then find the reflection coefficient and transmission coefficient HR and HGT. So the point is we are asked to find HR and GT, and this is the specified incident and the reflected and the transmitted. We know we will start from this equation Giz minus V1t plus HR, which is Z as less than 0 and Z as greater than 0. We have, this is the transmission. Let's suppose we have two media. This is media 1 and this is 2, and a wave of some specified shape is moving in this direction, and this is Gi, then it must reflect it HR, and it some transmission GT. Then this is the equation from the boundary condition 1. This is the first boundary condition because this is 0 minus and this is 0 plus, because these 0 minus 0 plus approaches to 0. Using this boundary condition, z is equal to 0 at minus and z is equal to 0 at plus. Then if we put here, then this will be equal to 0, this will be equal to 0, and which is equal to this. It means that the reflection coefficient, the incident wave, which is equal to the transmission. So this is the required result 1. Now from the boundary condition 2, this is the second boundary condition, which states that the differentiation of this function with respect to z at 0 minus, which is equal to the differentiation of this function z, this function with respect to z at 0 plus, this must be equal. Then I am trying to differentiate this, this, and this. So this is the differentiation. G prime means differentiation, and this differentiation, and this is also the differentiation. Here G prime I minus this is actually equal to partial Gi divided by partial Z. Now in your book we have already done this kind of chain rule, partial Gi divided by partial U and partial U divided by partial Z, where U is equal to this thing, Z minus Vt. If we differentiate du divided by dz, we will get 1. So this term will be equal to 1. And then at z is equal to 0, partial u, which is equal to minus partial v1 delta t. Putting these values here, partial gi divided by partial gz in this, then partial Gi divided by partial Z, which is equal to partial Gi divided by partial U, and partial U we have minus V1 delta T. So minus V1 delta T, and then this is equal to minus 1 over V1 partial Gi divided by partial G. And similarly, the remaining two parts will remain the same. The similar process we can do and can find out the partial G this GT divided by partial Z, which is equal to this. Now putting these values, this, and this equation 2, in equation 2. Then if we put all these values, we have this kind of things. And after taking minus common, and this minus will cancel with this minus, and then multiply V1 from this side. So this V1 and this V1 will cancel out, and we will have V1 divided by V2. After this equation with respect to time, if we integrate this, then we will have Gi minus V1 and this plus some constant of integration. This is equation number 3. Now we have two equations, equation 1 and equation 3. And we have to find out GT and HR. So how, now this is very easy to find out HR and GT. So first, adding equation 1 and 3. This equation and this equation. If we add this and this, then we have this kind of, the left hand side will add it with the left and the right with right, then minus HR and plus HR, this will cancel out. This Gi and this Gi will be 2Gi. This is a very simple algebra. And then you have this thing, V1 divided by V2, GT, and V also GT as. If we take GT common, then we will have 1 plus V1 divided by 2 plus K is the constant. And finally 2Gi, this minus K, which is equal to GT and this. And if we want to find out GT this, then we must remove this term. And this term will go to the other side, to V2 divided by V1 plus V2 Gi this and minus K V2 divided by this. And here, let's suppose K prime, this term which is equal to K prime. So this will be the GT, the transmission coefficient. Further, subtract 1 and 3. If we subtract 1 and 3, then we must cancel out some things from equation, from that equation. Let's suppose Gi, HR and Gi this is the left side, and subtract 3 GT this and to this. Then we have Gi, this one and this one. So Gi, this will cancel with this. Then we have 2 HR this, GT this. And we know now the value of GT we already have find out. Putting this value here. So this is a very simple mathematics, and 2HR which is equal to this is the value of this minus K. And after some mathematical steps, we can divide this 2. So this 2 will cancel with this 2, and K prime divided by 2 and minus K divided by 2. Further, HR of V1T which is equal to this term, and this is a very simple mathematics. Initially putting the value of K prime, this is the value of K prime, putting the value of K prime, and further after some mathematical steps you will reach to K prime, because here you must have minus K V2 divided by V1 plus V2. So please try to do this by yourself. Problem number 9.6. and states that formulate an appropriate boundary condition to replace partial f divided by partial z, which is equal to partial f divided by, for a case of two string under tension T joined by a knot of mass M. Here we have a knot, this is a knot, and we have a string here, and using the boundary condition and formulate a boundary. We have to find out a boundary condition, formulate a boundary condition using this diagram. We have this diagram. So from this diagram, we have this makes an angle theta plus, and at this side, this is the theta minus. So we have two components, one as the x component and the other one are the y components of this tension T. So at the y component, we have T sine theta plus, and this component, this is a T sine theta minus. So these two can balance the effect of each other. Then we can say that we have a mass M as well. Then the difference of these two tension T sine theta plus minus T sine theta minus, which is equal to ma. This is actually the second law of motion. So A is the acceleration, M is the mass of this knot. And now we are interested to find out what is sine theta plus. This is the differentiation of this function with respect to z at 0 plus and the other one as 0 minus. So putting these value in sine theta plus and sine theta minus, and also A, this is the function which is differentiation with respect to t 2 times. So we have, this is the acceleration. Then equation 1 implies that t, we can take t common and putting the value of this sine theta plus and sine theta minus. So we have this, which is equal to m partial square f divided by partial t square. So this is the boundary condition when we have a mass at the knot. So this is the final answer. The second point is find the amplitude and phase of the reflected and transmitted waves for the case where the knot has a mass m and the second mass is massless. We will find out the amplitude of the reflection coefficient and transmission coefficient and the phases as well. We will start from the very basic wave equation. This is a wave equation, AI tilde. This is the incident part, this is the reflected part, and this is the transmitted part. We know about this. Using the boundary condition first. This is the boundary condition first. If we apply this boundary condition, and then z, this term and this term will be equal to 0, we will have the exponential minus iota omega t here, here, and here. And these terms will also cancel with each other, and we will get this equation 1, ai plus ar, which is equal to at. Then using the second boundary condition, we have formulated here. This is the boundary condition. We will use this boundary condition, and for this we need to find out this term, and this term. So partial f divided by partial g, 0 plus. 0 plus at the 0 plus side, we have the transmission coefficient, this one. So we must differentiate this with respect to z, and then z is equal to 0. Then we will have this term. And partial f divided by partial t, 0 minus. So at 0 minus, we have the incident and the reflected part. And we must differentiate this, and finally we should putting the value of z. So after differentiation, we have this term, and partial square f divided by partial t square, we have this term. Now putting all these three terms in equation number 2, if we put all these terms in equation number 2, we will have this, and then after some mathematical steps we can reach to this equation, this one, k2 minus iota, because this iota will cancel with this iota. And this is a very simple, very simple mathematics, because we are interested to find out AT or K1 AI minus AR, which is equal to K2 minus iota m omega square divided by T and AT. And let's suppose this is equation number 3. Multiply equation 1 by K1 and then add with equation 3. This is equation number 1. Multiply equation 1 by K1 and then add to equation 3. So we have K1 AI plus K1 AR, which is equal to K1 AT. So this is the multiplication of K1, and then now we want to add with this equation number 3. K1 A1 minus K1 AR, this term, and I want to add this term, K1 AI plus K1 AR, which is equal to K2 minus iota omega t, and this is AT plus K1 AT. Okay, now let's see what we can cancel out. AR and AR, this will cancel with this, and we have 2K1 AI, which is equal to, we can take common from this, then we may have K1 plus K2 minus iota m omega square t and 2AT. And after finding this AT must be equal to 2K1 divided by K1 plus K2 minus iota m omega square divided by t and 2AI. So this is the AT. Now I want to write this equation here. Similarly, we must find AR. Then if we find AR, then from equation 1, AR, which is equal to AT minus AI. This is very simple. And now putting the value of AT from this equation, then this is not very complicated. AR, which is equal to find putting the value of this. So we have 2K1 divided by K1 plus K2 minus iota m omega square divided by T AI minus AI. So take common. So if we take common and also take the LCM, K1 plus K2 minus iota m omega square divided by T, then this is 2k1 minus k1 minus k2 plus iota m omega square divided by t, and this is ai. And further, this will be equal to k1 minus k2 plus iota m omega square divided by t divided by k1 plus k2 minus iota m omega square divided by tai. So this is ar. So I want to write down this here, ar. If the second string is massless, this is the condition. If the second string is massless, then what will happen? By definition, velocity, which is equal to t divided by mu, and mu is the mass per unit volume. So if the second string is massless, then v2, the velocity in the second string, will be, if mass per unit volume, this is the mass per unit volume, and this is massless, it means that this is equal to 0. This is this is very small, and this approaches to 0. If this approaches to 0, it means that the velocity, this velocity, will approaches to infinity. So this is the condition. If this approaches to infinity, then k2 divided by k1, the wave propagation, the wave number, must be equal to 0, because this k1 will be very greater than as compared to k2. So this must be equal to 0. This is actually, if we consider, this is k1 and this is k2. So here the mass per unit volume is very high as compared to this. Then k1 is very greater than as to k2. Then it means that k2 divided by k1 will be equal to 0. This is the condition. Now what will happen to this equation at and ar? We are interested to find out the at. So here, let's suppose this at, which is equal to, I can write down this k1 divided by k1 plus k2 divided by k1 minus iota m omega square divided by k1t, and this is ai. This will be equal to 1, this will goes to 0. Then at must be equal to 2 divided by 1 minus iota m omega square divided by k1t, and ai. And let's suppose this term, iota m omega square divided by k1t, this is equal to m omega square divided by k1t. This is beta. F m omega square divided by k1t, this is beta. Then this at must be equal to 2 divided by 1 minus iota beta, and ai. Similarly, the same process if we apply for this one, for this AR, then so AR, let's suppose K1 divided by K1 minus K2 divided by K1 plus iota m omega square divided by T K1 and divided by K1 divided by K1, K2 divided by K1 minus iota m omega square K1 T, and this is AI. Then this will be equal to 1, this will be equal to 0, this will be equal to 0, and this term and this term beta, so AR will be equal to 1 plus iota beta, 1 minus iota beta, and AI. So we find out AR and AT by using the condition when M2, the second string, is massless. And now we have this AT, which is equal to 2 divided by 1 minus iota beta AI, and AR, which is equal to 1 plus iota beta, 1 minus iota beta, and AI. So we have all these equations, as by definition A tilde, which is equal to A e की power iota delta. This is the definition because this is a complex one. A tilde is the complex one. Then AR, which is equal to AR e की power iota delta R, and AI tilde, which is equal to AI e की power iota delta I, and AT, which is equal to AT e की power iota delta T. This we will have. Now consider this equation AR, which is equal to 1 plus iota beta divided by 1 minus iota beta, and AI, and putting these values AR and e की power iota delta R, which is equal to 1 plus iota beta, 1 minus iota beta, and AI e की power iota delta I. So this is a very simple one. And similarly, for the transmission one, for this one, AT e की power iota delta T, which is equal to 2 divided by 1 minus iota beta, and AI e की power iota delta I. So we have these two kind of equation. If the second string is lighter, if the second string is lighter, then the first string mu2 is less than mu1. This is by definition. It means that v2 is greater than v1. That we already discussed this point. Then all the waves have the same phase. Then all the waves have the same phase. It means that delta I, which is equal to delta R, which is equal to delta T. So it has the same. So this is the one condition. further is AR e to the power iota delta r, which is equal to 1 plus iota beta, 1 minus iota beta, and AI e to the power iota delta I. Then AR divided by AI and e to the power iota delta r divided by e to the power iota delta I. We can write down this 1 minus iota beta. Then AR divided by AI, let's suppose this is A, and e to the power iota delta r minus delta I, which is equal to 1 plus iota beta, 1 minus iota beta. And this is the difference between two phases, and I call this phi, which is equal to 1 plus iota beta, 1 minus iota beta. Phi, which is equal to delta r minus delta I. The difference are two phases. This is phi. Now I'm looking for this A, such as A e to the power iota phi and e to the power minus iota phi. Then 1 plus iota beta, 1 minus iota beta, and the conjugate of this will be equal to 1 minus iota beta, 1 plus iota beta. Then this will cancel out, and this will be A square. And this A square will be equal to, this is equal to 1. It means that A will be equal to 1. If A is equal to 1 and putting the value of A here, then what will happen? So this is a very confusion here. If we find out A is equal to 1 and then put the value here, then we will have then putting the value of A e to the power iota phi, which is equal to 1 plus iota beta and 1 minus iota beta, because we put the value of A, which is equal to 1, and now we have this equation. Now from this equation we are interested to find out the phase and amplitude as well. How this is possible? Let's see. Iota phi, which is equal to 1 plus iota beta, 1 minus iota beta, and take the conjugate 1 plus iota beta, 1 plus iota beta. Then e to the power iota phi, which is equal to, this will be equal to 1 plus 2 iota beta, 2 iota beta plus beta square minus beta, because we have a iota square, then minus, and this 1 plus beta square. And from here, this thing is cos phi plus iota sine phi. And we want to separate the real and imaginary part here as well. 1 minus beta square, 1 plus beta square, this is the real part, plus 2 iota beta divided by 1 plus beta square, this is the imaginary part. Now compare the real and imaginary part. Cos phi, which is equal to 1 minus beta square divided by 1 plus beta square, and sine phi, which is equal to 2 beta divided by 1 plus beta square. Now from this tangent phi is equal to sine phi divided by cosine phi. Then sine phi, we have 2 beta divided by 1 plus beta square divided by cosine 1 minus beta square divided by 1 plus beta square. So this term will cancel with this, then tangent phi will be equal to 2 beta divided by 1 minus beta square. Now from this equation, AR, I want to find out the amplitude. AR e की power iota delta r, which is equal to 1 plus iota beta, 1 minus iota beta, and AI e की power iota delta I. And last time we have find out that this term e की power iota phi, which is equal to, I must note this one, iota phi, which is equal to 1 plus iota beta, 1 minus iota beta. So from here, if I put AR e की power iota delta r, which is equal to e की power iota phi AI e की power iota delta I. From here, the exponential term will cancel out. Because this is delta r, this phi is actually delta r minus delta I. This will cancel with this, and then finally we have the exponential term will cancel out, and the amplitude. This is the amplitude. If we look the phase also from this equation, if this is equal to this, then from this e की power delta r, which is equal to e की power phi plus delta I, then the phase are also equal. From this we have delta r, which is equal to delta plus delta I. Now we need for this phi, and this phi can be calculated from this equation, phi, tangent inverse of this. Then this delta r, which is equal to delta I plus tangent inverse of 2 beta divided by 1 minus beta square. And this is the phase of the reflected light. This is the phase of the reflected light. Similarly, we must consider this AT and find the amplitude as well as the phase of the transmitted light. Then we know that AT, which is equal to 2 divided by 1 minus iota beta, and AI. And this AT e की power iota delta t, which is equal to 2, 1 minus iota beta. The same process we must repeat. How? Because here, if I consider this AT divided by AI and iota delta t minus delta I, which is equal to 2 divided by 1 minus iota beta, and this, if I consider this is A and e की power iota nf, now this is delta t minus delta I. You may consider this phi some other angle. It depends upon you. That I consider this as phi. Then this is equal to phi, which is equal to 2 divided by 1 minus iota beta. And if I find out if I want to find out the value of A, then I want to multiply this by its conjugate. Then A e की power iota phi, A e की power minus iota phi, which is equal to 2, 1 minus iota beta, and 2, 1 minus iota plus iota beta. Then this will cancel out. A square, which is equal to 4, 1 plus beta square. and a will be equal to 2 divided by 1 plus beta square under the root. So this is the value of a. Then we go back and putting the value of a here from this equation. Okay, here putting the value of a in this equation, then the value of a 2 divided by 1 plus beta square under root e to the power iota phi, which is equal to 2 divided by 1 minus iota beta square. Sorry, this is simple beta. The conjugate of this, then 2 1 plus beta square under root e to the power this 2 divided by 1 minus iota beta, that we have the real and imaginary parts, then I will multiply and divide by its conjugate, 1 plus iota beta, 1 plus iota beta. Then 2 1 plus beta square e to the power iota phi, which is equal to 2 into 1 plus iota beta, 1 plus beta square. And then e to the power iota phi, which is equal to 2 and 1 plus iota beta, multiply this 1 plus beta square under root divided by 2 1 plus beta square. This 2 will cancel with this, and then e to the power iota phi, which is equal to separate the real and imaginary parts, then we must have 1 plus beta square under root divided by 1 plus beta square plus iota beta 1 plus beta square. And also we have 1 plus beta square under root. Now the same process, this is cosine phi plus iota sine phi, which is equal to 1 plus beta square under root divided by 1 plus beta square plus iota beta 1 plus beta square under root divided by 1 plus beta square. So the real and imaginary parts, now we can write down this separately. Here cos phi, which is equal to 1 plus beta square 1 plus beta square, and sine phi, which is equal to beta 1 plus beta square 1 plus beta square. And then tangent phi will be equal to sine divided by cos. Then I want to write down this if we divide this by this, then this term and this term will cancel out and we will have only beta. So tangent phi, which is equal to beta, and then phi, which is equal to tangent inverse beta. So in this case, we will have phi will be equal to this. And now go back to the equation. Which one? This one, at e to the power iota delta t, which is equal to 2 divided by 1 minus iota beta, and ai e to the power iota delta I. Here this term, I have considered this with a e to the power iota phi. Last time we have considered this. Then at e to the power iota delta t, which is equal to a e to the power iota phi, ai e to the power iota delta I. Then from this condition, we have at, which is equal to this. If this at, which is equal to a, I, from this condition, if e की power iota delta t, which is equal to e की power iota phi plus iota delta I. If these are equal, then it means that at must be equal to a and ai. And we know about the value of a. We have already calculated. And the value of a we already calculated is I think 2 divided by 1 plus beta square under root. This we already calculated, and AI. So this is the amplitude, and then find the phase from here. From this equation, delta t, which is equal to phi plus delta I, and we have already calculated phi here. Then delta t, which is equal to delta I plus tan inverse beta. So this is the final transmitted light, phase of the transmitted light.